Hey everyone, welcome back to the channel. My name is Patrick and you're watching The Everyday Machinist. And in today's video, I'm going to be discussing how to achieve really good surface finishes on a quarter radius, corner profile like you see here in this part. Now I have two examples. One was done with a pretty conventional tool and one was done with a very unconventional tool. I'm going to explain how I achieved these surface finishes here a little bit later in this video. But let me explain the backstory. These are examples or cutaways for the C10 dashboards. And now I made several billet C10 dashboards for Virgin Raceworks. And if you're wondering, I do have the video. I'm just waiting to release that. They're doing their own kind of video, their own promotional video that they're going to release. Out of respect, I'm just going to wait for them to do that, and then I'll release my video. All right, so let's talk about some of the basic tool. And we all know for producing corner radiuses and profiles. That is a corner rounding end mill. Pretty standard. They come in many different sizes, and you can even have a custom profile made that suits your needs. The other tool that everybody should know is a ball end mill. This particular one is a 3-foot, 1/4 inch reduced shank from Helical Solutions. Okay, this tool I utilized in making this example here. The corner rounding end mill I did not utilize because I don't have that size. I don't have a 1/2 inch radius corner rounding end mill. And to be honest with you, it wouldn't have been the best tool for this particular feature on the C10 dashboard, so I just chose not to purchase one to try to do it. And in all honesty, it really wouldn't have, I don't think it would have been the best surface finish to achieve, just due to some of the complexities in that part. And I'll explain that a little bit here soon in this video. The last tool that is not conventional is a 3-flute, 3/16 diameter, 30 thou corner radius end mill. You might think to yourself, well, why would you do that, right? Well, I actually achieve the best surface finish with that tool, and I'm going to explain that. And it all comes down to chip thinning. And now, again, let me preface it. This is because we're only utilizing a 3-axis vertical mill. Obviously, if we had a multi-axis machine, we can then utilize different portions, different areas of this ball end mill to achieve just as good or better surface finish. But you be the judge. You see the difference between the ball end mill and the corner radius square end mill, and you let me know in the comments below. All right, so what you see here is a representation of the outside profile of the C10 dash. Okay, from what we see here is we have a 1/2 inch radius to a 100 thou flat, and then it steps down 60 thou into the pocket. And we used a 3-flute 1/4 inch ball end mill. This one's Helical Solutions. It is a reduced shank, and I forgot the helix on it, but pretty generic ball end mill. Okay, this is one way we could do this feature. Now, of course, if you have smaller features, you can use a quarter round. This is a corner rounding end mill. Okay, This is not for that size. Obviously, this is just 1/4 inch. But you can imagine it would be a pretty large tool to be able to do this in one shot. It's give or take for a corner rounding end mill to have a consistent tool path. And you don't want to take that chance, especially if you have an unsupported part. It's very big. And of course, we would adapt it down, rough it down, get close to the shape, and then come in with a finishing pass for a standard corner rounding. But it wasn't feasible in this situation. So my concerns, right, with experimenting with this is that when you have a 1/4 inch ball end mill, you run into what they would call chip thinning. Now, chip thinning is because the flute is great on the side for the majority of this tool. As it gets to the center point of this ball end mill, well, it's really no longer cutting. There isn't an efficient amount of cutting area or flutes to be able to achieve a great surface finish from about 20 thou out on this particular tool. Now, again, let me preface it this: we're talking about a 3-axis vertical machine with no additional axes. So that's where this is going to focus on. Of course, you can manipulate the tool if you have a multi-axis machine to then efficiently cut on a single point on a ball end mill, on a specific area on a ball end mill to achieve a superior surface finish. Of course, we know that can be done. But that's not the case on a 3-axis vertical milling machine, or even a horizontal machine, most likely. So again, as stated, this ball end mill ran from the bottom up, and I really don't think that matters, but from the bottom up in a horizontal tool path in a flow feature in Fusion 360. The issues that happen, now the surface finish looks great, right? We have really good transparent surface finish. But as you get a little closer to the part, as you can see here, you can start to see the cusps in the part here, okay? That's going to be there. I don't think anybody would disagree with me on that. The issue is, as we get closer to the top, and you can see it here, and the camera may not do it justice, but lighting wise, as you get closer, and you can see it right there, it's with the lighting, it's actually with better lighting. I don't want to move the light around too much, but better lighting, it actually starts here. It really starts to fail on cutting this upper portion before it gets to the land. I'm sorry if that's hard to see, but the land is here to there. So you're going to see here, just start seeing it there. It is a terrible surface finish. And I don't mind the cusps. Okay, that's going to be there for a ball end mill. But you can see right there. See it? From there to there. Here's the land, start of the land. Here's the end of the land. From there to there. It's just a terrible surface finish. It's not consistent all the way up. And the reason is because as this ball end mill is working its way up to the top, it's no longer cutting. It's more chip thinning or rubbing the part versus cutting. All right, so that's not an ideal to have a qualified final product, right, without any polishing or doing anything like that. Or even if you are polishing, it might be just a little bit more work to blend that in. You're gonna have to spend time to blend that in, and you might have an inconsistent thing if you're doing it by hand. Okay, I don't think that's the best way to do that. So what I have done, and I have done this before quite some time ago, and I kind of forgot it because I'm stupid and I don't write things down, but now I do. But quite some time ago, I discovered that I could use a 3-flute corner rounding. So this is a Helical Solutions 3/16 end mill corner rounding. Basically standard end mill with a corner radius on each flute, 3-flute here. Okay, and go back 1 second. This step over was done at 3% of the tool diameter. Okay, the industry, I think from searching online and looking at what other people, kind of doing my research here, what other people would recommend or say is that on a ball end mill, it's about 4 to 14, 5 to 15% step over. So the smallest number I saw was 3%. And I would agree with 3% on most of these features. It looks really well. Okay, but at 3%, so that's 7.5 thou step over. So you're still seeing those, okay? Which is fine. Like I said, it's a completely acceptable surface finish for the majority of this profile. But as you get closer to the top, it starts to really rub into that part, and it's not cutting. So that 1/4 inch ball, we used a 7.5 thou step over, which is 3%, which is fine. But if you look at this part, far more consistent. Virtually no or unnoticeable chip thinning at the top. And I think it's really due to, if you see there's one little line there, and I think that's just because it was a shorter engagement because it met the land. So I could have probably eliminated that with changing a slight bit of the cusp height or step over. The reason why we achieve this, now this tool, okay, is run at 1.5% step over. Okay, so it's about 3 thou. Why didn't I do that for this? Well, for the 1/4 inch ball end mill, you're going to start to see, and I'm sure some of you have seen that. Sorry about the part, it might be a little scratch. I've been handling a lot. But you're going to start to see these little spots, little white spots here, here. You're going to start seeing, it's actually, you can see it looks like little tiny nicks or dinks in there. Okay, that is foreign objects or recutting chips, and it's being reintroduced to the surface as that ball end mill is coming up. So if I went tighter with that step over, less than 3%, it would be far more significant of having those surface defects. Now I could probably go to like 3, you can really start to mess with it and go maybe 9 thou step over to try to eliminate that, but then your cusp heights and your scallop heights would be far more significant, noticeably in the surface. So even with a whole bunch of flood coolant, you're still going to have those surface imperfections. And of course, like here, as I can see here, a really terrible chip thinning and more tool rubbing than it is cutting. All probably from about here to here. So it's close to being about 25 to 30% of this half-inch radius profile here, of where the top surface in the right light is just going to look absolutely terrible. So back to this one. So we have 1.5% step over. It's about 3 thou on a 3 flute, 30 thou corner radius, and they make 20 thou, a 10 thou corner radius. It really doesn't matter. I just happen to have this one. And I know it works. But if you look, the surface finish is fantastic. You really can't see, or the cusps are extremely tight. And then you can see here as it runs right into that flat spot, that land. It's really just a really nice approach to it. And of course, on the land, you just ran a facing operation, so you're going to see a little bit of lines from the end mill. I just use an end mill to do that. But you can see here, I actually scratched it from touching it there, but don't worry about that. But here, you can just really see. I mean, I don't think the camera does enough, but I think right there is the money shot there. It really is a nice surface finish. And they're very close to the same amount of time. So kind of keep that in mind when you're trying to, if you're fighting a ball end mill, go to this. And again, I think both of them are 10,000 RPM, 2.5 thou per tooth, and they're both 3 flutes. So surface footage is going to be a little bit different because of diameter sizes, but it's going to be very close. And it's amazing to me, even on a 3-axis, to achieve that. I mean, it looks amazing. So keep that in mind when you're you're struggling and fighting with a ball end mill and trying to do all these different things, you know, utilizing this 3-flute corner radius. And again, the reason is we don't have chip thinning on this corner radius end mill, because as the corner comes up, right, as the side of the flute comes up, it goes into a 30th corner radius and it starts to run flat. Okay, so as we're doing that, we're always going to have a decent amount of cutting surface. Now there is chip thinning, but again, it's primarily cutting always on a radius, all right, just like a ball end mill. But by the time it gets to the bottom of that tool, or the tool is running flat, it's more acting like it's facing operation versus a contour operation. Also, a ball end mill in a cam profile, in a cam program, it's referencing off the center of the tool, okay, versus a square end mill, or we'll call it a square end mill, with a corner radius or corner rounding end mill, it's still referencing off of the side of the end mill. So the program sees it as the side. So the offset is from the side. On a ball end mill, the offset is from the center. So as it gets closer and closer, you know, and it has to utilize that. And again, in a multi-axis machine, we would then change the angle of that. Well, we can't do that here. This is just a 3-axis machine. And to be completely honest with you, this works so well. I mean, you cannot argue with that surface finish. This 3-flute works so well. So if you're struggling with contour features, profiles, or radius features like that with a ball end mill, consider using this. And again, it's, you know, 2/9 chip load per tooth. And this is 1.5% step over to achieve that. So hope you guys understand. I hope you can see it really well. You can see the differences right there. I mean, this is not a fail. This is a very acceptable finish, except the last portion as you get up to here. It's not. And there's really no difference in cut times again. I mean, you're talking less than a minute in difference in cut times. And speed doesn't matter. We're running 2.5 chip load per tooth. And, you know, these high efficiency tools, these modern tools carbide tools can cut minimum 10,000 RPM all day. That's what I utilize for these. And you can obviously do less, 4,000. It's just your chip load per tooth that really matters. And obviously your step over. Now, tool stability, machine stability, rigidity, all that stuff, it's going to play a factor, obviously. But let's put that aside because we're specifically talking about a tool and a profile. So hopefully you see the difference as I see the difference, and how you wouldn't think that you can use a 3-flute corner rounding, technically square end mill, to achieve a better surface finish than you would with a ball end mill. All right, so hopefully everybody was able to follow along and understand my explanation on achieving this really good surface finish on this radius, contour, or feature here on this test part. Now again, this is just my opinion. And also keep in mind, we're limited because we're utilizing just a 3-axis vertical milling machine. A lot of people out there have just a 3-axis vertical milling machine. They don't have access or the capability to utilize multi-axis machines to be able to create that surface finish, that consistency on a part like this. Now again, it's totally acceptable with this ball end mill, and you would have to probably go back and do some finishing work, some polishing to really get it to be consistent. Well, we're trying to reduce that method or completely eliminate it by utilizing this corner radius 3-flute end mill. So if you understand and you're able to really see in the previous clip in this video where I explain, and hopefully I did it well enough, to explain how the ball end mill is not the best tool to achieve that surface finish and that consistency throughout that profile. If you think I did a good job, please drop a comment below. If you think I didn't, please drop a comment below. I respond to all comments that are reasonable. Again, like, share the video. If you're new here, please consider subscribing. If you have subscribed, I want to thank you for coming back and watching the video. I really appreciate it. It really motivates me to put out more content and give everybody my view, my viewers and subscribers, my opinion on where I came up with these processes or these problem solving different techniques, right? So that's going to be the biggest thing. I kind of look at, I've only been doing this for 6 years. So I have no prior knowledge or experience before that. So as a company, I went all in. I started out with one machine and then slowly grew. So then, I had to kind of learn on my own and figure things out on my own, and try to see what the industry expects of me versus, I have to solve a problem right now. Do I conventionally do something, or do I unconventionally do something and possibly fail? But I figured out a way that, maybe that's not going to work. Let's try this way. And that's ultimately what led me to figuring out that I can utilize this corner radius 3-flute end mill to achieve a better surface finish than the 1/4 inch ball mill here. So again, I'm just new to this industry. So I've went back and I know I've watched videos of other channels, other shops that where I needed to learn something. I needed to figure something out. So me doing this is kind of me paying the way forward. Trying to give my interpretation on solving these problems and getting really good surface finishes. So again, I want to thank everybody for following along and watching my videos and all the comments and the likes. I really do appreciate it, especially the shares. You guys have been sharing the heck out of this channel. So I really appreciate that. Some new stuff coming up also some old stuff. We're definitely going to wrap up the stainless helm adapters. So that's coming here pretty soon. We did have to make a couple changes. I'll explain that in the video. Thankfully, it's due to the customer, but thankfully we didn't get far as long as we were supposed to, waiting on the customer, where we realized we needed to stop and rethink something because something was missed. So thankfully we're able to get to a point where we weren't at a total loss, but that's coming up. Also some other new stuff, some new products that I've been developing here for better shop air quality. So you'll see that. I'll bring that out on YouTube and hopefully get everybody's reaction on something like this. And again, it's just supposed to make the air quality, the machinist life, a whole lot better for a whole lot less. So we'll get into that in another video when I'm at that point. And again, the C10 dashes will be coming out when I get confirmation that they're all done with what they want to do with their social media on that. So look forward to that. And again, I want to thank everybody for watching the video. I really, really appreciate it. It really humbles me a lot to see the engagement and the conversations that happen with my videos. So again, thank you. I hope everybody has a great day. Check back here soon for more videos. And we'll see you on the next one. Thank you.